Hey gang, Landon here again. So this is part 3 of my multi-part videos, and the first two parts, the first one was about like the planning stages, like laying out a board, making sure that we got the like a solid wiring diagram to know that we got the right cable sizes and the right fuses and all of that type of stuff before putting it together. Number 2 was a bit more about getting it together, and this one, number 3, is going to be about turning it on and a few things to set up type things. So I guess I got it in, and it was a pain. It's definitely a two-man job. Do not recommend doing it on your own. These multi-pluses are pretty heavy. I don't know the exact numbers, 30 something kilos. It feels like they're 50 kilos. They're just they're crazy heavy, and so it's very biased. It's very heavy on this end, and I'm a little bit tight with space as well. So our bus isn't a huge bus. It's sort of like a country school bus, so the bins aren't real big. They're not, I'm grateful for having bins as well. So, but anyway, so the first things that we can do is to check connections, that they're tight, that they're connected in. We can do our visual checks as well, so checking that the red is going to the red hole, which in this case for my batteries they're orange cables. So these are manufactured cables that come with the batteries. They're called Amphenol connections on the ends, and they go orange and black is their color scheme, I suppose. I run Pylontech batteries in our bus. I don't put Pylontechs in buses anymore, and there's a reason around that. I'm still running them in my bus, and I've still got lots of buses out there, and I'm still happy with them. It's just there's a slim chance of them having something vibrate loose in them and causing troubles down the line. So, and we've had good luck with them. We've done thousands of Ks, but anyway, that's for another video, I suppose. But so checking that as well. And something you might have noticed on my system, that there's no shunt. So there's no smart shunt or anything like that, and that's because our batteries communicate directly to the servo. So they have this cable here, which is called a CAN bus cable, and that plugs into the batteries to give us the state of charge and temperatures and cell balances, error codes, all sorts of stuff. So having a managed battery there is a self-managed battery is definitely of benefit. And what happens too is that becomes the master and everything else becomes its slave. So it tells the chargers when to stop, and it throttles the chargers back when it's getting near full, and a few things like that. But there's still an important factor about setting up the correct settings in the chargers. So because they control that, but what happens that if we lose that communications, we still want to make sure that the settings in the charger go to something that are going to appease the battery. So it's important to make sure we get that right. But let's just at the start, what we'll do is check all of those connections, check our connections on the inverter, that they're still good. Make sure as well that we haven't like wiggled anything loose, and there's nothing obvious hanging around that needs to be tightened up type thing. So then we can go ahead and either connect our batteries or turn them on, whichever your batteries do. So some of them have like a bit of a startup procedure. So these have a startup, and they should all come on. They are just been slow, but then we should get a battery voltage at the top of this isolator. It's a little bit hard to see, and this is where it's where it is painful showing on the videos. So what we can do is we can check for voltage on the top of that isolator to make sure that we're getting some battery bank voltage there, and then we can go ahead and turn that one on. And what we'll notice is that things will start flashing and starting up. So the servo's coming online, the solar chargers are coming online. We've still got the solar isolators in the off position, and we'll check that one again in a minute. And we've also got the MultiPlus in the off position. So before turning any of these things on, what we want to do is just to make sure that we're getting what we expect in voltage wise at the terminals. So this one is saying 49 or 50 volts, somewhere around that, and that's what I'd expect out of the batteries. And we can check their polarity on here as well, so that's, yeah, flicking between 49 and 50. They're all good, we checked all of those. But so then what we can do is we can go ahead and turn the MultiPlus inverter on. So they just have a 3-position switch, and it's in, I call it in towards the front, this being the front and the where you mount it being the back. So it's in towards the front, and you'll hear they'll have a bit of a click. There it goes, and it'll start humming away as well. I've got all my circuit breakers on. We had this going all night last night. I only got it in late last night. There's the pump building pressure. We've got an accumulator tank on there, and that'll stop in a sec. But another thing that we can do as well, that this is probably the good time to be setting up the settings on the solar chargers before us giving it any solar voltage. So on the Victron Connect app, we want to go to the little cog. We want to first join the network, do any updates that it's required, press on the little cog up the top, battery, and then we can go user defined, and we can set up our own parameters with our charging, our absorption and our float charges based on what our battery manufacturer say, because I'm not a real fan of, they have some pretty generic numbers in there, and I'm always a fan of making sure that that's what our battery manufacturers set, that they want. They all argue over that. Some charge at, for a 12 volt battery 14.4, some are 14.6, and all sorts of different numbers. And sometimes as well, the solar chargers, if the first time they've been powered up, they also have like the battery voltages. They can be throwing and screaming alarms, and people are sometimes ringing me in a panic that it's yelling over voltage alarms. And they standard, I don't know, it feels like they pick a number out of a hat out of 12, 24 or 48, and they see this 49 or 50 volts coming in, and they're like, man, this is not good shit, like we've got problems. So as smart as they are, they've got a bit of things that information that we need to feed them type thing. So setting up those voltages on the SmartSolar is definitely what we need to do there. And then what we can do as well is before turning them on, so we first set up the battery charge rates. I'm not sure if you can hear that pump, but it'll stop in a second. So I have labeled these, a bit hard to see, but it's negative, positive, so we can check to make sure that that's correct. And what we can do as well is then just to see how our meter reacts when it's in the opposite way. So, and that's showing minuses, and I've got the red in the red hole and the black in the black hole. So that's what we expect it to be, 79 volts, and that's 4 solar panels. They're wired 2 series, 2 parallel, so that's what I would expect. So that's my big bank panels, and then this one here is coming in at about 110, so which is 3 panels in series. So, and that's about what I expect there as well. So that now that the battery is right, the polarity is right on the solar cables coming in, and if they weren't right, this is a good opportunity to swap them around carefully here, or unplugging on the roof before we change these terminals in here. But then we can go ahead and turn these on. There's no, I don't have any cables in this third one, which is this one here. That's going to be for our trailer. So that's not been used yet, but that's going to be wired into there. I need to run those cables to the back of the bus. But that is about all that we can check on here. There's a couple things that I might show you on the touchscreen upstairs inside the bus, and that's just before plugging in the extension lead and to be testing that, because it's a good test to do. But there's a couple of things to check first, and to see that what we're looking for as well is that these things are communicating. So we might grab my coffee and we'll head up there, and I can show you what the things to check up there. So welcome upstairs to our bar. So what I've done for our screen is I have extended the USB and the HDMI by about 2 meters. It sort of comes up through the floor. The off-grid system is basically under us right here where we are. So it's coming up through the floor behind the fridge and along the way type thing. And I find that extending them about 2 meters, sometimes 3 meters, works fine with just a USB and a HDMI extension. But if we go further than that, it is ideal to plug in the USB locally. So it's got a short USB cable, so then to have like a USB point, behind the fridge on the wall or something like that to plug that in. So the USB is for the power only, the HDMI is where it's for the touch and the display. So that's a handy little tip to have. But so what we're looking for on here is we're looking for things to be communicating. So we have the batteries communicating, which we can show you in this screen as well. So that's the Pylon-Tech battery. So this is where it tells us the battery state of health, its state of charge, and tells us like how many modules are communicating and that type of stuff, which is really quite handy. We have the MultiPlus inverter charger communicating, which is important, and we also have 3 solar chargers, and we have a water tank with an error code. So I reckon that error code is because there's 3 different ports to plug the incoming tank sensors into, and I reckon I plugged it in the wrong one. So we can have a look at that, and I can plug that into the right hole. But something that I wanted so that's the first thing to check. It's to check that we are getting all of the things that we expect to be communicating. So that's all of the things that we have plugged in. It's good that we have the water tank in there, and that's something that I need to a change there to get to work. But that's one of those things of what happens when we're plugging stuff in. It's finding what's not working and then working from there and fixing it. But what I want to show on the MultiPlus, they have in these settings, what we want to do is to adjust this one here, input current limit. So this here is how many amps is coming into the system in AC amps. So for some reason beyond me, it presets to some ridiculous high amount. So like the amount that it's going to dim the lights in the neighbor's house, it's something ridiculous, and I'm not sure why, but it's important before we go plugging it in to come in and to set this at a lower rate. So all of the inverters have a minimum charge rate, and for the 5 kVAs it's 6 amps, and I'm a huge fan of charging things slowly. I've talked a fair bit about heat, and one way to keep things cool is to charge them slow. So, and we have the benefit where we are here to be able to charge when we need to. We're at a friend's place. He's got a big solar system, so I charge during the day if I ever need to, which I think today it might be, because yesterday the solar system was out all day, so we might need some charge today if I have the aircon on. But anyway, it's good to set that input current down fairly low. So that's definitely a good thing before plugging it in. And something that it's a good opportunity before we plug it into is to set up the charge rates inside of the MultiPlus. So the MultiPlus requires either a Mark III adapter, which is a cable that goes to the computer, or I can program these remotely as well. And I have a little video which shows how to set this up to allow external communication, so then I can log in through the VRM to set that up remotely. So that's always a good idea. But what I will do now is to set that up remotely, log in on the computer, set those settings correctly, and then I will run a test of plugging it in. And under the MultiPlus, what we can do is we can see here the AC in. So that's when it shows us voltage and amps, watts and hertz on the incoming power. So sometimes when we plug it in, we can see this rise up, and it'll have 0 amps, 0 watts, and then it'll wait a little minute, and then it'll connect. So they're waiting for the sine waves to be in sync basically, and then they will connect. So So that's you know, a handy thing to look for when we're connecting, just to see if it's seeing, if the MultiPlus itself is seeing the voltage. So sometimes they will see it, but then they won't start charging. So on this display, this is the, I'm not sure what they call this UI, if it's the original or there's also a new interface as well with a big black circle, and I'm not a fan of the new one yet. I'm so accustomed to this one, and I love this. Easy to read and you get used to things. But up here is where it shows the incoming power. So from the shore power, this one here is the AC load. So that there is the all the power coming out of the MultiPlus. And then this one here is the solar. So this is all of the combined solar charges. So that says 900 and something watts, and that's 500 and 400. So that there, or roughly adds up, doesn't it? But and then that one there is the battery percentage. So there is sometimes as well, if we have DC loads connected directly to the links distributor, so things like a 48 to 12 volt converter that doesn't communicate directly through the V direct cables, what we do is we can set that up in here. It's under settings, and we go system setup, and we go, this one here has DC system. So then we can go back. So what that does, it makes a new box down here, and mine's not reading much. It says -7, which in those low numbers, I'd almost call that a 0. But what that is doing is that it knows these numbers. It knows what's coming out of the battery, and it knows what the AC loads are, and it knows what the solar's doing. So it's doing some really simple maths, and it's dumping all the other loads into that DC power. So say if we were drawing 100 watts to charge, you know, to run a diesel heater, or not that they use 100 watts, but you know, things like that on a 48 to 12 volt converter or a 48 volt fan, and that type of stuff. So so then it would show up there. It would show up like a number there. So my system's a little bit different the way we do our 12 volt. I can do another video on that, but yeah, I'll go back downstairs and I'll talk about a couple other things, and then we'll wrap it up. Righto, so we're back downstairs, and I'll have a look at that tank sensor. So I'll try it. There's 4 channels, so I think number 3 might have been where it come from. I thought it was number 2, but we'll try that, see if that fixes the tank sensor. But otherwise, from here, it's about putting the duct cover on. So that's going to cover up all of the cables. I can put some more cable ties on. I'll put a few on those battery cables coming in. Also might put a bit of slotted duct on those cables just down there, in case I've got something here that's going to slide and knock against them. So the slotted duct just, again, gives it that little bit of extra protection for those cables. So and that's like the slotted tubing thing. What do you call it? Like slotted conduit, maybe. Something that the automotive sparkies love to use. But so that's what I'll put there. There's a bit of AC wiring going on here as well, and there's also a earth connection, which is what is required in AS 3001. It's about the chassis being earth of the bus. So the bus's chassis and the metal framework of the bus becomes its return path under fault conditions for an RCD to operate. So it's important to get those correct. So then the next stages would be to have your Sparky finish off the 240 volt wiring and run some RCD tests to test that functionality. So so that would be the next thing on the list. There is I did have another thought process actually, and I'm going to run through this potentially in the next video, but is ideas about keeping this cool. So because I've you know, been, it's a little bit, it's not a little bit tight, there's still a good like 50-60 mil above the inverter, and there's 90 on this side and 75 on this side, so I've still got plenty of space around the inverter. But what I do want to do is to introduce some cooling into here, some ventilation. So I'm going to cut a vent on the fan, a fan vent on the lid or the bin door of the bus, and I'm going to control that through the Servo GX with monitoring the temperature and turning the fans on and off. So it's a super handy thing to have. So the Victron have, it's called the VRM, which is Victron Remote Management, and that's where we can log in remotely and see what's going on to the system. The system does need to be connected to the internet, but it's also a good place where if it is connected to the internet, that it's constantly uploading the data. So then it really helps us fault find to have that data over, you know, a long period of time. And I used it. I had a problem with one of my solar chargers, and I could look back on the VRM and I could spot where it changed. So it was, you know, going from whatever, taking 100 volts and then it changed type thing. So so it's a handy thing to have, is the VRM connected to the internet. And on that as well is that the servos do have Wi-Fi built into them, but the Wi-Fi connection isn't great in my experience in these type of structures where excuse me, where there's so much metal and interference and that type of stuff. It might work well if it's in a timber gyprocked house that it's, you know, on the other side of the wall type scenario. But here, you know, we've got the big metal batteries, we've got, this is all metal, and it's terrible at picking up the Wi-Fi range, and it's only probably 3 meters above us in the inside of the bus, under one of the front seats is where the Starlink router is. But what I find is to be a way more reliable connection is to run a LAN cable or a Cat5 cable or an internet cable, whatever you want to call it, down into the servo. So they've got a port up here, the front right hand port, if you like, if you're looking at it the right way around. So that's quite handy thing to have. But yeah, from here I've just got to put that slotted duct cover on, put the bottom of the MultiPlus on, do those RCD tests, neaten up with that bit of slotted conduit stuff. There's a couple of cable ties there that need to be trimmed off, and then yeah, it's all ready for our adventure. We're heading off on a short trip to Victoria to Off-Grid Living Festival, so we'll be there talking on stage, and yeah, it's going to be a nice little trip away for us, and then we're coming back here to South Australia to finish a trailer build, and then we'll get going for a bigger trip this year, hopefully up to North Queensland. So anyway, that's it for me for now. Let me know if you've got any questions. I think the next video that I make is going to be about the installing of the fan and a vent, and how to set that up on the servo to control the turning it on and off and that type of stuff. So I think that's a super handy feature to have on the servo, and I love doing it for other people's systems, and now it's finally that I get to do it for my own. So that's pretty exciting. But anyway, good on you guys. I will chat to you soon. Cheers.